Exercise 16.3, question number 8. Three coins are tossed once. Find probability of getting. First one is three heads, two heads, at least two heads. First, let me start by writing the sample space for the coin or three coins. When they are tossed, the sample space is going to be 2 power n, here 2 power 3, which is going to be equal to 8. When three coins are tossed, the sample space is going to be 8. The possible outcomes have been given over here. These are the possible outcomes, which is also known as sample space. Now, let me consider the first one. Let A be the event of getting three heads. Number of possible outcomes. What are the possible outcomes where you can get three heads? Only one possible outcome is there. Probability of event A is going to be 1 over the sample space, which is going to be 8. This will be your answer. The second one, again, 2 power 3. So sample space is going to be 8. Let me consider the second one as event B, probability of getting two heads. Number of possible outcomes where you can get two heads. What are the possible outcomes where you can get two heads? Over here, over here, and over here. Other than that, there is no possible outcome. So 1, 2, and 3. So totally 3. Probability of event B is going to be 3 over 8. Next one. Let me consider C to be event of getting at least two heads. Two or more than two heads I can consider over here. This can be considered, this can be considered, two heads, this can be considered, this can also be considered. There are four possible outcomes. The probability of event C is going to be 4 over 8. Upon cancellation, I will be getting the answer as 1 over 2. Moving on to the next one. At most two heads. Let me consider D to be the event of getting at most two heads. At most two heads means two heads or less than two heads. That is what at most two heads means. Now, all the possible outcomes can be taken, but except TTT. Except TTT, everything can be considered. Probability of event D is going to be 7 over 8. This will be your answer. I think somebody is there. Just let me in. Moving on to the next one. Fifth one, let me consider this to be event E of getting no head. This is the probability of getting no head. Probability of getting no head. So there is only one probability where you will be getting no head, that is TTT. Probability of event E is going to be 1 over 8. Next one, three tails. Again, probability of getting three tails. Let me consider this to be event F. Probability of getting three tails is going to be only 1. So probability of F is 1 over 8. This is going to be your answer. Moving on, question number 9. If 2 over 11 is the probability of an event, what is the probability of event not A? Not A means complement of A. I know that probability of event E plus the probability of complement of event E or not E is going to be equal to 1. If this is true for event E, this will be true for event A as well. In this question, 2 over 11 is going to be probability of A. We have to find out probability of not A. Substituting the same in the formula, I will be getting the answer as 2 over 11 plus probability of not A is going to be equal to 1. Probability of not A is going to be 1 minus 2 divided by 11. Taking the LCM, it is going to be 11. Cross multiplying, it is going to be 11 minus 2. Probability of not A is going to be 9 over 11. This will be your answer. Question number 10. A letter is chosen at random from the word assassination. Find the probability that letter is first sub question a vowel, second sub question a consonant. First, let me write down this particular word which is given. Total words or total letters are going to be total letters in this word is 3, 3, 3, 1, 10, 10 plus 3, 13. 13 letters are there in this particular word. Number of vowels. A, E, I, O, U are vowels. How many vowels are there? 1, 2, 3, 4, 5, 6. 6 vowels are there. Let me mark this with yellow color. I. These are your vowels. Next. Consonants. How many consonants are there? 13 minus 6, it should be 7. All the other letters are going to be consonants, which are not vowels, they are consonants. First sub question, what is the probability that the letter is going to be a vowel? Let V be the event of getting a vowel. Probability of event V is going to be, there are 6 vowels divided by totally there are 13 letters, 6 over 13. The second one, probability of getting a consonant. Let C be the event of getting a consonant. There are totally 7 consonants. The probability of event C is going to be 7 over 13. This will be your answer. I will be moving on to question number 17. A and B are events such that P of A is 0.42, P of B is 0.48. Here P of A means probability of event A, P of B means probability of event B. Probability of event A and B is 0.16. Determine P of not A, P of not B, P of A or B. We have to find the probability of all these events. Let me write whatever is given to me in the question. Probability of event A is 0.42. Probability of event B is 0.48. Probability of event A and B. A and B is 0.16. 0.16. First, let me write down first sub question. Probability of not A. I can write this as A dash. We have to find out probability of A dash. I know from the formula that probability of A plus probability of A dash is going to be equal to 1. Is going to be equal to 1. I know the probability of A, I can find out the probability of A dash. Probability of A dash is going to be 1 minus 0.42. 0.42 is going to be probability of A. The first answer is going to be probability of A dash, which is 0.58. This will be the answer for first sub question. The second sub question is P of not B. P of not B, I have to find out. Again, I can write the formula P of B plus P of B dash is going to be equal to 1. I know the value of P dash. PB is going to be 0.48. I can write 0.48 plus P B dash is going to be equal to 1. P of B dash, probability of not B is going to be 1 minus 0.48. Probability of not B is going to be 0.52. This will be the answer for second sub question. The third sub question is P of A and B. Sorry, P of A or B. P of A or B. What is P of A or B? P of P of A or B is P of A union B or intersection. This is going to be union. Whenever you have or, it is going to be union. Whenever you have and, it is going to be intersection. I can write the formula as probability of event A union B will be given as probability of A plus probability of B minus probability of A intersection B. I have to find out A or B, meaning A union B, I have to find out. A union B, I have to find out. Substituting all the values, probability of event A, it is 0.42 plus probability of event B, it is 0.48 minus probability of A intersection B. A intersection B means A and B. A and B, it is already given. It is 0.16. Probability of event A union B will be point 0.9. This will be 0.9, 0.9 minus 0.16, 0.74. Probability of A or B will be 0.74. This will be the answer for third sub question. Moving on to question number 18. In class 11th of school, 40% of students study mathematics, 30% study biology, 10% study both mathematics and biology. If student is selected at random from the class, find the probability that he will be studying mathematics or biology. Mathematics or biology. This is what we have to find out. So let me write what is given to me in the question. Probability of, before this, let M represent mathematics, let B represent biology. Let me start with this. Now, probability of students that study mathematics is given as 40%. 40% can be written as 0.4. 40 divided by 100, which is 0.4. 30 study biology. Probability of biology is 0.3. 30%, which is 0.3. Next, 10% of the class study both mathematics and biology. And means intersection. P of M intersection B is going to be equal to 0.10. 10%. We have to find out the probability of mathematics or biology. Or means union. Probability of mathematics union. This is question. If there are two events M and B, then the formula is going to be M union B will be equal to probability of M plus probability of B minus probability of M intersection B. Probability of M union B will be equal to probability of M, which is going to be 0.4 plus probability of B, which is 0.3 minus probability of A M intersection B, it is going to be 10%, which is 0.1. 0.1. Here the answer is going to be probability of M union B will be zero point 0.6. 0.6. So I can tell that 60% of the students study mathematics or biology. This will be your final answer. Moving on to question number 19. In an entrance test that is graded on the basis of two examinations, the probability of randomly chosen student passing the first examination is zero point 0.8. The probability of passing the second examination is zero point 0.7. The probability of passing at least one of them is 0.95. What is the probability of passing both? Let me consider. Let probability of passing the first exam, probability of passing first exam be A. I will be taking probability of A as zero point 0.8. Next, let probability of passing the second exam be B. Probability of event B is 70%, which is zero point 0.7, zero point 0.7 or 70%. Probability of A union B is going to be at least one exam. So let me write down over here. Whenever you have at least, it will be A union B. Whenever you have at most, it is going to be A intersection B. Here, what do I have to find out? I have to find out the probability of passing both. Probability of passing both. Both means it is at most, meaning that A intersection B is what you have to find out. A intersection B is what you have to find out. Is it clear? A union B is already given, that is 0.95. At least one of them. At least means A union B, it is 0.95. Substitute everything in the formula, you will be getting the answer. Probability of A union B will be equal to probability of A plus probability of B minus probability of A intersection B. Probability of A intersection B. Substituting all the values, 0.95 will be equal to zero point 0.8 plus zero point 0.7 minus probability of P intersection B. I can transfer probability of A intersection B to the left hand side. It is going to turn to positive sign. Probability of A intersection B will be equal to 1.5 minus 0.95. Probability of A intersection B will be equal to zero point 0.6, zero point 0.6 minus 0.55. 0.55. This is going to be the probability that student will pass both the examination. It is going to be 55% or 0.55. This will be the answer for question number 19. Question number 20. The probability that student uh, will pass the final examination in both English and Hindi is zero point 0.5. The probability of passing neither is zero point 0.1. The probability of passing the English exam is 0.75. What is the probability of passing Hindi examination? Let me start by considering. Let E be event of passing English examination. English exam. Let H be event of passing Hindi exam. Okay. Now, what is given in the question? it is already given that probability of event E, the probability of event E is going to be 0.75. Probability of event E is 0.75. Probability of H is what we have to find out. This is what we have to find out. Now, what will be the probability of A union B? What will be the probability of A union B? Probability of A union B is going to be equal to, they have given that the probability of passing neither is zero point 0.1, neither is zero point 0.1, both is going to be A union B, meaning that A union B will be equal to 1 minus probability of neither. Probability of A union B will be equal to 1 minus zero point 0.1. This will be equal to 0 0.9. This will be equal to 0 0.9. We have the value of 0 0.5. 0 0.5 is English and Hindi, and is a intersection which is E. This is not A and B. I have taken as E and H, right? So let me write as E and H. Probability of intersection of E and H is given, which is 0 0.5. Substituting in the formula, probability of event A union H is given by probability of event E plus probability of event H minus probability of E intersection H or H intersection E. Both are one and the same. This is going to be 0 0.9. 0 0.9 will be equal to 0 0.75 plus probability of H minus 0 0.5. We have to find out probability of H. Probability of H is going to be minus 0 0.5 minus 0.25. Minus 0.25 and 9.65. 0.65. 0.65 is going to be the probability of passing Hindi examination.